So guys, going forward, now in this slide let us try to understand that what is the semantics of layer 3 routing information. That is, what information actually is called layer 3 routing information. How does layer 3 routing information looks like, right? So now let us try to first understand that what are L3 routes. So L3 routes are nothing but it is layer 3 routing information, right? So the layer 3 route is an entry in the routing table. So remember that layer 3 router has a special table called layer 3 routing table. And the entries in this layer 3 routing table is called an L3 route, right? So L3 route is an entry in the routing table of a layer 3 router, and this entry tells the router the next router in the topology to forward the packet to, so that the packet eventually reaches the destination subnet, right? So layer 3 route is that information in the routing table of the router using which the router knows the next router to which it should forward the packet so that the packet eventually reaches the destination subnet, right? If every router in the topology forwards the packet correctly to the next router, then the packet certainly will reach its destination machine, right? So layer 3 route is actually made up of 3 entities. Now what are these 3 entities? So the first entity is actually the destination subnet. So destination subnet means the network ID of the subnet in which destination machine is present, right? The second entity is the next hop IP address. This next hop IP address we also call it as gateway. So gateway is nothing but it is the peer interface IP address which leads to destination machine subnet. And the third entity is the outgoing interface. That is, it is the local outgoing interface to reach the peer interface. So now let us take an example to understand that what exactly layer 3 route is. So let us take an example. Suppose we want to teach the router VM how to reach remote subnet 192.168.1.0, that is subnet 2. So we need to teach, or we need to program the router VM that if it receives a packet which is destined to any machine which falls in subnet 2, then what should router VM do with such a packet? So in order to feed this intelligence in router VM, we need to install the following layer 3 route in the router VM, right? Now what does this line say? You can see that this line has 4 parts. The first part says that you are adding an entry in the routing table of router VM, right? Then the second part is actually the destination subnet, which is actually the first entity of the layer 3 route, right? So you can see that 192.168.1.0 followed by net mask 255.255.255.0 is actually can be written as 192.168.1.0/24, right? So this mask, that is 255.255.255.0, can also be written as simply /24. Then the second important entity in this layer 3 routing information is the gateway IP address, right? So 192.168.4.1 is the IP address of a peer interface. So remember, it was the second entity of the layer 3 route. And the third important entity of the layer 3 route is the local outgoing interface. That is, in this case, the local outgoing interface is Ethernet 2. So you can see that we have specified a complete layer 3 routing information using this command. And once this command is installed in the router VM, then the router VM will know that if it receives any packet whose destination IP address is a member of this subnet, then the router VM will going to forward the packet out of local interface Ethernet 2 towards the gateway IP address 192.168.4.1. So simply after feeding this entry in the router VM will get the following intelligence, right? So from the above entry, machine VM knows that whenever it has to send the packet to remote machine whose IP address is of the following type, that is 192.168.1.0, and the last octet of the IP address could be anything. Because if you specify any value in the last octet of this IP address, this IP address will always going to fall in subnet 2, right? So the router VM has to send the packet out of interface Ethernet 2, that is the local interface, towards the peer interface whose IP address is 192.168.4.1, right? So by installing this entry in the router VM, we have actually given the intelligence to the router VM that how it should treat the packet whose destination IP address is such that the destination IP address falls in the subnet 2, right? So now let us take another example. Now in this example, we will teach router VM2 how to reach remote subnet 192.168.4.0/24, that is subnet 1. So for that you need to again install a layer 3 routing information in the routing table of router VM2, and for that you can use the following command. So you can see that you are specifying the remote subnet 192.168.4.0/24, and in order to reach this remote subnet, the gateway IP address is 192.168.1.1 and the local outgoing interface is Ethernet 3, right? So from the above entry, the machine VM2 knows that whenever it has to send the packet to remote machine whose IP address is 192.168.4.x, where x value can belong to 1 to 254. Then the router VM2 has to send the packet out of local interface Ethernet 3 towards the peer interface whose IP address is 192.168.1.1. So now if you install this entry in the router VM2 and if you install the previous entry in the router VM, then the router VM can ping router VM2 and the router VM2 can ping router VM. So now from router VM, if you try to ping an IP address 192.168.1.1 or IP address 192.168.1.2, then you will be able to ping. Similarly, from the router VM2, if you try to ping an IP address 192.168.4.1 or an IP address 192.168.4.2, you will be able to ping. Meaning that your router VM now knows how to reach a machine which is present in the remote subnet 2, and the router VM2 now knows how to reach a machine which is present in remote subnet 1. So conclusion is that the layer 3 routing entries are required to reach any non-local subnet, or in other words, layer 3 routing entries are required to reach a machine which is present in the remote subnets. And always remember, layer 3 routing is all about sending a packet from source machine subnet to destination machine subnet. So there is a difference between destination subnet and destination machine, right? Destination machine is present in a destination subnet, and in destination subnet there can be many machines, right? So once the packet reaches the destination subnet, then it is the job of L2 routing to take the packet from destination subnet to the destination machine, which is actually one of the machines in destination subnet. We have already discussed this when we were discussing the overview of layer 3 routing.